Okay, recording is live. Good morning, students. Today is Tuesday, April 14th, and we have a dual credit lecture to get through today. I don't really have any emails to address, but if any of you have any questions as we are going, just ask live in chat, and we'll get to them probably right after the lecture, I guess. Yeah, I guess let's get this show on the road. So as far as class announcements are concerned, I don't really have anything unless you are working on the extra credit project. You do have a checkpoint due tomorrow. It's the first one where you actually have to do a little bit of work, so be sure y'all are submitting that. Remember, if you do miss a checkpoint, then you are no longer eligible for the extra credit. Other announcements? I don't think I have any. So, might as well get this started. Okay, so dual credit, this is going to be your last lecture. So, after today, we'll be ready for the exam. Thursday, we're not having a lecture. I'm just going to have office hours for the rest of the week, but at some point, you should probably look at the test review, ask whatever questions that you need to on the homework or the test review. And I need to make sure that y'all are ready for this exam. Exam 3 is going to be the same as we did last time, where you're going to have a PDF. You can write on the PDF or print it out and write and take pictures, whatever you want to do. And then you're going to submit it back online on Blackboard and on Google Classroom. So there were a couple of you that had issues with Blackboard. You should have them resolved by now. If you have not, then you need to, because now it's going to, for most of you, we got it all sorted out. So it is going to be non-negotiable. You have to submit it to both. All right. Other things? Yeah, just both classes are going to have a test next week. So be ready for that. I've had some questions about if we're actually going back to school this year. I don't think anybody knows. My educated guess is probably not, but it's a guess. Nobody knows. You have several school districts, even in Dallas, even in Texas, they've already closed for the school year. So I'm assuming there's going to be a chain reaction event, kind of like come down through to Houston. And probably, but you never know. We could be back for the end of the year. So keep your options open, I guess. Okay, so polar coordinates today, last section of chapter 6, and we are done with the chapter. Dual credit, after we take the test next week, I'm going to talk a little bit about what we're going to do before the final. Anyways, we'll get to that next week. All right, so what is a polar coordinate, this thing that we're talking about today? Normally, whenever you talk about a coordinate point, we talk about the XY coordinate plane. And you have a point, and it has an X coordinate and a Y coordinate, because the X coordinate tells you how far left and right to go. The Y coordinate tells you how far up and down to go. So this could be something like 1, 3 or something like that. So instead of talking about left and right and then up and down, the polar coordinate is r, theta. So in other words, how far away from the origin you are, and the angle from 0 degrees you are. So there's 0 degrees. R is going to tell you how far from the origin you travel, or kind of like the hypotenuse of the triangles we've been drawing the whole time. And then theta is how much have you turned. So let's flip to the next slide real quick and we'll come back. So remember, with angles, you're allowed to add or subtract 360 degrees or 2 pi over and over and over again, and you end up in the same spot. So let's go ahead and plot this first example, 3, 60 degrees. Let's come back here. So here's 60 degrees, or pi over 3. From the origin, you come out 3 spots, and that is the coordinate point 3, 60 degrees. Right there. See? So the 3 is the length from 0, 1, 2, 3. And 60 degrees is where you turned in relation to 0 degrees. Now remember, you can add or subtract 360 degrees. So if I spin around in a full circle or I add 360 to this, 420 degrees represents the exact same coordinate point. So whenever it says multiple representations, you can add or subtract 360 as many times as you want, and you're still talking about the exact same coordinate point in space. And that's something that didn't happen with xy coordinates. The r is called a directed distance because if you have a negative r, you travel backwards. So if I take this same coordinate point and I decide to do negative 360 instead, you face towards 60, but instead of stepping forward 3 spots, you go backwards 3 spots. So if you go 1, 2, 3 right there, that would be negative 3, 60. So it's exactly 180 degrees away from the other one. So with the combination of adding and subtracting 360 and using positive r and negative r, you can come up with problems that'll ask you, hey, I want a coordinate point. Tell me all of these different ways that you can represent that coordinate point. And of course, you don't need this grid in front of you the entire time, but you do want to know how to represent based on what angle you're facing. So you'll do the angle first and then worry about r afterwards. So here's an example. Plot the point with polar coordinates 3, 225. So if we're just doing this by hand, here's 0 degrees, 90, 180, 225 is right here, halfway between 180 and 270, and then you want to come out 3. So 1, 2, 3. So there's my point P. So notice how I kind of read this backwards. I did the 225 first, and then I stepped out 3 spots. Now, I want to use that same coordinate point, but I want to write the numbers differently. How do you represent it with a negative r and an angle between 0 and 360? Well, if I know I want to face this way by the end of the problem. If I want a negative r, that means I have to go backwards. So that means I have to face this direction. And then once I face this way, you step backwards 3 spots. So I need to know what is this angle right here. So it's exactly the opposite of 225, or you turn around, do a 180. Right? This would be 45 degrees. And then you step backwards 3 spots. So the coordinate would be negative 3, 45. Okay. All right, part C. Now I want a negative r again. So that means I want to face towards 45, but now I want a negative angle. I want an angle between negative 360 and 0. So I know I want to face that way, the 45, because I have to have a negative r. I have to step backwards in this problem. But I need the angle to be negative, so I'm just going to subtract 360 from it. So negative 3 again. But now if I do 45 minus 360, I get negative 315, which is coterminal to 45, right? It's the same angle as 45. I just subtracted 360. And then part D, positive r, negative angle. Positive r implies I have to actually face the direction I want to go, but now subtract 360 from there. Right? So 225 minus 360. So negative 135. Which again is coterminal to 225 degrees. So that's all the different ways. All 4 of these coordinate points, part A, part B, part C, part D, they're all representing the exact same point in space. All right, so there's a lot of problems in this section that ask you to convert between polar and rectangular, is what we call the old XY coordinate point system. If you just think about, let's say I pick a polar coordinate somewhere over here, right? Well, the polar coordinate would be r, theta, so I would know how long that vector is, and I would know that angle. So if I want to think of it in terms of x and y, I need to know how far over I go and how far up I go. Well, you create a right triangle whenever you try to find those pieces. If you know the hypotenuse and theta, you can just use trig to find the adjacent side and the opposite side. Because remember, SOHCAHTOA. So sine would be opposite over hypotenuse, which would be y over r. So just multiply the r over. And that's this statement. Cosine theta would be adjacent over hypotenuse, so x over r. Then multiply the r over. That would be this statement. So if you have polar form, you can convert back to rectangular form by just using trig. Okay, so let's do that. Convert the polar coordinates to rectangular coordinates. So you have 2, negative 30 degrees. Draw a sketch if you need to. So negative 30 would be, 330 would be right here. So go out 2 spots. Sorry, I should take that dot off. There we go. So there's a negative 30. There's 2. So there's my theta. There's my little triangle I'm drawing. So my x would be r times cosine theta. So that means x is going to be 2 times cosine of negative 30, which would be the same thing as cosine of 30, which would be square root of 3 over 2. And those cancel, x equals square root of 3. So that's my x coordinate. My y coordinate would be r sine theta. Well, sine of negative 30 is just negative sine of 30, which is 1/2. So negative 1/2 here. And the 2's cancel here, so y is negative 1. So my rectangular coordinate is square root of 3, negative 1, which is in quadrant 4 like I expected. I'm gonna eat this bagel here, hold on. So notice how we still can't get away from the unit circle. Wow, this bagel is rock hard. Thank you, kids. They mean well. That's all that matters. Okay, so negative 4, pi over 3. Pi over 3 would be 60 degrees in degree world, so I'm facing right here. But I'm going backwards 4 spots. So 1, 2, 3, 4. So there's the coordinate point. There's my little triangle. So again, x equals r, which is negative 4, cosine of pi over 3, which in this case would be 1/2, x equals negative 2, y is negative 4 sine pi over 3, come on. How do you get rid of this easier? There we go. There we go. So y would be negative 4 square root of 3 over 2. And y would be negative 2 square root of 3. So again, I'm in quadrant 3 like I expected. I have negative 2, negative 2 root 3. Oh, right. I'm writing behind my face. Here, let me move that real quick. There you go. There's the work. I'm having too much fun with this. Need to do the DVD bouncing thing like in The Office. Can eventually make it back. Oh, whatever. Okay. I'm bored. All right, moving on. Again, we're doing this conversion from one to the other. So we talked about converting polar to rectangular. Now, how do you convert rectangular to polar? What if you already have xy coordinate points and you want to change into r and theta? So really, the r is easy because you just do Pythagorean theorem. I don't think most people are going to have an issue with that. But the angle is going to be dependent on which quadrant you're in. Because when we use inverse tangent, remember, inverse tangent can only give me answers between negative 90 and 90. And that's not going to be representing every single possible angle from 0 to 360. So we're going to find the reference angle. We're going to draw the little triangle in our quadrant, do the all students take calculus thing, and then use the reference angle to find the real angle. Right? Because remember, everything is from 0 degrees. So let me show you. Okay, find me polar coordinates, and they're specifying the rules for r and theta, right? Because you have an infinite number of ways you could write it, just like we saw back here. And now the rectangular coordinates are -2, 2 square root of 3. So if I do a quick sketch of that, -2 would be back here, 2 square root of 3 somewhere up here. So I know the x coordinate, I know the y coordinate. I want to find r, I want to find theta. So the reference angle is over there in quadrant 2. So let's do the easy part first. Let's just do Pythagorean theorem. R squared equals x squared plus y squared. Let's plug in the numbers we know. So here we get 4 plus 12, square root of 16, r is 4. Okay. Great, so we know the hypotenuse of the triangle. Now we want to find the reference angle. So when I do inverse tangent, when I set up my little triangle here, tangent is not going to be of the actual theta, it's theta prime according to this textbook. That's equal to opposite over adjacent. And now we're just going to use 2. I'm not treating this like it's in quadrant 2, I'm just treating it like a triangle that I would just solve in normal life. Or geometry, I guess. I don't know why I said life. Okay, so pretend it's a geometry problem. We had no coordinates to begin with, and we just have a little triangle in space. So 2's cancel out. Tangent theta prime is square root of 3. So inverse tangent both sides. Inverse tangent square root of 3, which is 60 degrees. Or, oh, they want radian, so pi over 3. Pi over 3 is not the answer. Pi over 3 is how big that angle is. We want from 0, we want that angle. So we need to do 180 minus our angle, or in radian world it would be pi minus our angle. So r theta is going to be pi minus theta prime. So pi minus pi over 3. So our theta is 2 pi over 3. So our final answer, our actual coordinate point, 4, 2 pi over 3. And that fits the rules they wanted, because we wanted a positive r and we wanted an angle between 0 and 2 pi. And if the radians are bothering you, convert to degrees, do the problem, and convert back. I know a lot of you have been doing that already. Okay. All right, moving on. Last thing we're going to do with polar stuff is, and we talked about converting already with coordinate points. Now we're going to take equations and convert them back and forth. So you have both directions, rectangular to polar. Remember, you have the equation that x equals r cosine theta, y equals r sine theta from this. So you can actually use that in equation form too. If you have a rectangular equation and you want to convert to a polar equation, then do those substitutions and have an equation in terms of r and theta. If you want to go from polar to rectangular, you've got all these tools you can use. And we'll use all of them on the next slide, or 2 slides from now. Okay, so take this equation and convert to polar form. All right. So if you don't recognize this, it's an equation of a circle, right? Center of 1, -1, radius square root of 2. Now, how do you recognize, how do you actually do that in polar form? Well, we're going to take x and replace it with r cosine theta. We're going to take y, replace it with r sine theta, and then we'll try to simplify the equation. So, r cosine theta minus 1 squared plus r sine theta plus 1 squared. And now everything in my equation is now r's and thetas. So I'm going to have to FOIL both of these, and then I'm going to have to write everything out. And the next line is going to be a big mess, but we are going to combine stuff here. So FOIL the first one, we get r squared cosine squared minus 2r cosine plus 1. The second FOIL, we have r squared sine squared plus 2r sine theta plus 1. All right, good so far? Okay, the only like terms we have are this one and this one. So I'm going to do a little rearranging. I'm going to put the r squareds together. So you've got r squared cosine squared plus r squared sine squared minus 2r cosine plus 2r sine plus 2 equals 2. It's a lengthy problem, I know. Now these 2's actually cancel out, because if you try to subtract 2 from both sides, it's the same thing on both sides of the equal sign. So all you have left is r squared cosine squared plus r squared sine squared, and then you have the 2r cosine, 2r sine. Pay attention to the squareds. I'm going to take just these two, and I'm going to take just these two, and I'm going to do a little factoring by grouping, I guess, if that makes sense. Do you remember that from a long time ago, from your college algebra days? So over here on the left, I'm going to factor out r squared. Actually, we can just leave this alone. What would be shorter? Because I'm running out of room on my whiteboard. Running out of room on my slide. Yeah, this is fine. Okay. We're just going to leave it alone for now. We'll factor it out on the next step. Now the whole reason I factored out r squared on the left-hand side is because I have a Pythagorean identity from the last chapter. Cosine squared plus sine squared equals 1. So now out of all of these, you got r squared minus 2r cosine plus 2r sine. I can factor an r away from all of those. And now we're basically to the answer. I have an equation that has parentheses, so I can use zero product property. So either r equals 0, which doesn't make any sense, right? R equals 0, that doesn't make sense. Or r equals 2 cosine minus 2 sine. Remember, they would switch signs when you move them over to the other side. And I do want to show you one thing before I forget. There is a way for you to graph polar on your calculator. And not many of you have ever seen it before, so I'm going to show you. So you head over to your calculator, you hit mode, and you haven't ever had to mess with this before, but down here, function, this stands for parametric, this stands for polar, that stands for sequential. We're going to hit polar. And now, instead of x and y, you have r right there. You can hit 2 cosine. And now when you hit this button, it puts a theta instead of an x. See that? We might have to zoom trig again. Oh no, I'm already set to zoom trig. Yeah, this isn't. Oh no, we need to do a zoom fit. Okay. There we go. Zoom fit. Oh, come on. It's a circle, but there we go. Good enough. Remember, it's a little oblong because the x and y aren't the same. What if we zoom square? Would that look better? Yeah, there we go. I just hit zoom square. So it is a circle at 1, -1 with a radius, some weird small decimal radius. So you can do polar stuff in your calculator. Okay, I just wanted to show you that before we were done. All right, now we're going to go the other way. We're going to take polar equations. Oh, I'm sorry, Julia. I just saw your question. So back here. Okay, so I'll just talk you a little bit through the steps one at a time, and you just let me know if there's something confusing. So first step, I subbed in for x, I subbed in for y. I did r cosine for x, I did r sine for y. Next line of work, I foiled both. So this is the result of foiling the first parentheses. This is the result of foiling the second parentheses. You still had the 2 over here. And then going from line 2 to line 3, I rearranged the problem. I put the r squared terms together. And then I combined the 1s. That's all that happened from line 2 to line 3. All right, and then you get here, you factor out the r squared. So these both have an r squared. I factored it away, and all that was left is cosine squared plus sine squared, which is a Pythagorean identity for 1. So here, this second to last line of work is r squared minus 2r cosine plus 2r sine. All 3 of those terms have an r. So I factored the r away from all 3 of those. So that's why this r is on the outside. So what would be left over? This r squared would still have an r. This would no longer have a 2, so -2 cosine. This would no longer have an r, 2 sine. And then you factored something with terms of r, kind of like you would have x in a rectangular equation. So one solution is r equals 0. That would make the whole thing 0. But that doesn't make sense because that's not an actual equation. But what's left over is this thing equals 0. So to get that box equation, I just added the 2 cosine over to the right, and then I subtracted the 2 sine over to the right. So the parentheses set it equal to 0, and then get the r by itself. Hopefully that made sense. That's why, you know, -2 cosine down here becomes +2 cosine up here. Okay, awesome. Thank you for the question. Okay, so last slide. We're going the opposite direction now, which these are actually shorter problems, except they have more tricks because of the fact you have more things you can substitute in. Here, this direction, you know exactly how you're supposed to start every single one of these. X gets replaced with r cosine, y gets replaced with r sine. There's not many decision points to make here. Polar to rectangular, you have all 4 of these you can deal with. So r equals 3. Well, do I have an easy substitution for r? Well, I don't, but I could square both sides, which is a trick you're going to use in this section. Well, why would I do that? Well, now it says r squared equals 9. And I didn't have a sub for r, but I do have a sub for r squared. R squared says x squared plus y squared. And guess what? That is a circle with a radius of 3, and that's exactly what r equals 3 means. See? Circle, radius of 3. Center is 0. Okay, part B over here. Theta equals 45 degrees. Now the trick here, because I don't have a direct sub for just theta, but I do have a sub for tangent theta, so I'm going to tangent both sides. And that gives me tangent 45 on the right. Well, tangent of 45 degrees is 1. And and tangent theta is y divided by x. See that? So you can multiply the x over y equals x. So theta equals 45 degrees is just a straight line. Okay, r equals cosecant theta. The trick to starting this problem is recognizing cosecant is 1 over sine. So you can multiply the sine over to the left. R sine theta equals 1. And r sine theta is y. So y equals 1. So this is a polar equation for just a horizontal line at 1. And then finally part D, it's going to be similar to part A, except the trick here is I can multiply both sides by r. R squared equals 2r cosine theta. So here I multiply both sides by r. So that gives me x squared plus y squared equals 2x. And technically you can just be done here. There is more stuff you could do to this equation because it is an equation of a circle. I don't know. I don't know if my math lab is going to make you do it or not, because as long as you're in terms of x and y, I think you're done. Let me just show you the rest of what you could do to simplify just in case. I'm not quite sure if they'll want it or not. Let me move my face out of the way preemptively here. All right. Because what you could do to continue the problem is you could subtract the 2x to the left. And then you could complete the square with the x's. I can add a 1 to both sides, because that gives me x minus 1 squared plus y squared equals 1. And technically that's another way to simplify it, because the center of the circle would be at 1, 0, and the radius would be 1. And you could verify that with your calculator if you just hit 2 cosine theta. See? Center at 1, 0. Radius of 1. I guess you can zoom in if you want. There you go. Okay, and that is polar, and you are now done being lectured in dual credit pre-cal. Congratulations, you made it. You're at the finish line. You're at the end of the year. Okay, so you've got a homework to do. You've got 6 homeworks to do for the exam. It is much shorter, but make sure you're getting your homework average up as high as you can. I do have an announcement. I'm going to wait for tomorrow to announce it, but just please be sure to take advantage of office hours. Be sure to email me ahead of time so I can address them on stream, or just log in and ask in chat. Let's see. Oh no, I guess that's pretty much it. Yeah, if you have any questions, then let me know. I'll be answering questions in office hours for the rest of the week. I do have an announcement for tomorrow, and if you are doing the extra credit, your checkpoint number 2 is due tomorrow. And all my deadlines are going to be at midnight, if you haven't caught on to that by now. So, that is all. Y'all have a fantastic day, and I will see you soon.